Let's demonstrate the constant pointer. So this constant pointer, the const keyword will be associated with the PTR variable name, the pointer variable name. So through the pointer, we still can update the data, but this PTR cannot be reassigned. So that's finished with showing in the IDE. So here I declare another constant pointer. So this constant pointer, after we declare this constant pointer, we need to right away assign. So then here, after I declare the constant pointer, I still can, using this constant pointer, CTR, to dereference. So then they will display the value for x. So then after I display the value for x, I still can using this CTR to reassign the x value. So you can see after I reassign the x value equal to 300, later the x will be 300. So then we see here, we run the program, what happened. Yeah, I have one variable I declared that earlier, I didn't remove that. Okay, so we see what happened. So you can see here, you have a constant pointer. So that's this CTR can have the value referred to x. So that's why we display x actually 4 times. So now I can using the CTR to reassign the value equal to 300. So they will affect to the x variable. So that's why when we display the x variable again, or we're using the PTR to display, they are all 300. So then you can see here I have 120. That's because I want to show you the other one. So when you have your constant pointer, you only can declare and assign in one line. So since that's constant pointer, I declare another variable y. So this variable y, I want to reassign CTR to the location for y. So then you will see after I comment out this one, because the CTR is a constant pointer. So when I reassign to y, we see they should have an arrow. Okay, so they told you assignment of read-only variable CTR. So the CTR actually is a constant variable. So that's why they cannot be reassigned. So that's the arrow came from. So then let me comment that out. So then we can rerun again. So that's the second way you can using the const keyword to associate with the pointer. But you can see because your const keyword location is different, they associate differently. You use the const keyword associated with the pointer variable. You make this pointer variable become constant. They cannot reassign the location. Then you have your constant keyword associated with the data type. That make this pointer to refer to a value. They cannot be reassigned from the pointer. So then, of course, we have the last one. If I have a constant pointer to refer to a constant data, this one actually will be like this. So the constant pointer to a constant. This pointer actually will point to a constant data. They cannot be overwrite. So this pointer actually cannot point to anything else except what they are pointing to. So that's why when you want to declare a constant pointer to the constant data, you need to have the value of the variable assigned right away. So that's why we right away assign that. But one thing is, you see, you cannot reassign the value. You cannot reassign the pointer. The only thing you can do is you can still see out the PTR. So because they are read only. So then of course I want to show you in the IDE. So this one is, right, I create a constant pointer called CTR. They point to a constant value, but that's point this value to y. So then you can see after you refer to y, right, I can still display the CCTR value. But here, if I display the CCTR value using the dereference, they will display y value is 20. So then you can see here, right, I can display again. Okay, but later I will show you they cannot be reassigned the value. So that's why we just make our program can run. So I just want to show you, right, our CCTR display the value is 20. But then, like we say, you cannot reassign, right? So that's why CCTR, when I want to reassign to X, they will have error. When I try to using the CCTR to reassign the location value, they will be compiling error. So that's why you can see you have two compiling error. We have that here. The first thing, you try to using a read-only variable CCTR to reassign. Then the second one, you try to assign the value, the location is read-only. So that's why they have the issue. So I want you to try on your compiler, because different compiler, they give you different error message. So in order to make your program run correctly, of course, we need to comment this out, these two lines, because they cannot be assigned. So that's our constant keyword to associate with our pointer. So after you understand all that, so now let me show you again before when we do our array passing by the pointer. So we see, supposedly we have the following definition. We have the array size, because this array is the static array. So then here the size needs to be a constant variable. So then when we pass in the array, how can we pass in through the function? So right, you can pass in the array through the function using the array symbol. Our array name actually is a pointer, so you can do the double pointer like this. And don't forget, you need to pass in your size. So you can see here the size is a constant number. But when we pass in the size, you see here is int size. We are passing by copy. So you don't need to worry, they just copy the 6 to the size variable here. But this one, remember, we show you because that's the display pay rate function. So your purpose, yeah, definitely you can define your function like this. But in C++, we really care about the security. So that's why when you pass in an array, your purpose just want to display the information. Because here, no matter you passing by array or passing by pointer, you both passing by reference. So when you passing by reference, on the other hand, mean the local function has the right to update the value in the array. So maybe you have some accidentally update the value, you didn't know that. So then later your program will have some error data. So in C++, we really care about the security. So we give the programmer the flexibility is, if your purpose passing the array is for the read-only purpose, so then, right, you should do is, we can still do the display rate like this. But you can see because our purpose is only do the display, right? So that's why when you pass in the array through the function, we really want you to do is, you should add your const keyword. Because the purpose is, you are passing by read only. So when here, if you have a pay rate array, they are just regular array. So you can either pass in with constant keyword, without the constant keyword. Either way is fine. But one thing is, if you already know your function is for the read-only purpose, it's always highly recommend you should do this way. You need to pass in by const. Okay, so then sometimes because we are not really sure, right? So then when we have the display pay rate, we know this pay rate, I don't want them to be changed. So that's why we can either have the function we're passing the by constant keyword. So that I want you to download example 13 to see how we will do that. But also we have the other way is what? Supposedly we have the pay rate. Since we already know this pay rate is fixed, I don't allow people to make the change. So one thing is we can do is, how about I just declare this array, all the value is a constant double. So when you have constant double array like this, what does that mean? That means once you have your array declared, all the data, they cannot be accessed. So then if you have a constant array, you want to pass in this constant array through the function. Can I write a function like this? Right, this one is function code, right? I just want to pass in the pay rate from array through the function. This function code. But how should we implement the display pay rate function prototype? So then you will see here, a constant array only can be passing with a read-only pointer. So you need to be careful. Earlier, if I don't have the const keyword, I pass in the array with the const keyword or without the const keyword, they are all okay. But if you have a constant array, when you want to pass in this constant array through the function, when you do your function definition, your function definition has to have a const keyword to associate with that. If you don't have this const keyword, then you will have compiling error. The reason is because your pay rate already been defined in the constant. So compiler, when they see the constant kind of like a protection for the data. So compiler see they have a constant keyword. So then when you have a pointer, you want to refer to the array. So this pointer need to have refer to the constant double data type. So that's why they can be matched with this one. Okay, so that means both using the red color. So you know this one actually is matching with this one. So then you can run the program. So let's see here, we do the example 13.1. So then I will show you how they will work and how they won't work. So this one, like we say, in the main function, I have the size equal to 6. I declare my array contain constant double. So that means all those values cannot be updated later. So then you see here, then we just call display rate function. I pass in the pay rate, array name, and size. So then you have display pay rate. Because this one is constant double. So your data type for your pointer need to be constant double. So then when I pass in using the rate pointer name, so then we can using the rate associated with the count. So that's why you can see they can display the data correctly. Okay, so you see the data displayed correctly with the 2 decimal points. Okay, so then let me show you 2 things. The first thing is like earlier we said, this array is a constant double array, right? So that's why you see in the main function, I try to update a constant double. So I will assign this value to 10. So we see what happened. You see the first thing, because this one is the constant double, you try to reassign, then sorry, you have the error. So then you see here, after we comment out, then your program can run fine. Now the second thing, earlier we told you, right? You see, you have to have the constant keyword. So now if I say here, if this function, I don't have the const keyword, I try to pass in a constant double through the regular double array. So then you see the pointer refer to the non-constant pointer to refer to a constant double. So then you will see here, right? Again, you have error message. Okay, because they say you have invalid conversion. Because one thing is you have this pay rate is constant double, but you try to assign them to the regular double pointer. So that's why you have the error. So that's why here